Hello guys, this video is for Algebra 2, Week 7, Monday and Tuesday. This lesson is not going to be very long because there's only one formula that I want you guys to learn and actually refresh because you probably have learned it back in freshman year, I think. So we are learning geometric sequence and exponential functions for starting this week. Okay, so exponential function, it looks something like this. We always start out with f of x because it's a function, and we have two numbers, which is a and b, a times b to the x power. Okay, whenever you see something that's to a power of x, then that means we have to be dealing with exponential. Okay, and b right here is something that we keep on it's a number that we raise it to the x power, right? So let's say if x is like 2, that means I want to multiply b itself twice, okay? And then the front number, so b is kind of like the rate. So a is usually the initial amount for anything. Like what do we start off first? That would be your a, okay? So I'm going to show you guys two sequences here. Sequences are just like patterns, like what we did at the beginning of the year. If I have 2, 4, 6, 8, 10, 12, dot, 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 and I have 2, 4, 8, 16, 32, 64, dot, dot, dot. What's the difference between these two sequences? The first one, we kind of start off with like the same two numbers, but then you notice that we are actually adding 2. We keep on adding 2 to get to the next number, right? And then for the other one, we are multiplying 2 to get to the next number. Okay, and these two sequences, we have a name for each. The first one, when we add, we are talking about arithmetic sequence, which means you add to get to the next number, adding exactly the same amount to get to the next. And then this other one, where we multiply exactly the same number, it's called geometric sequence. Okay, and we are focusing on geometric sequence today. We're not looking at arithmetic today. And there's a formula that's very similar to the exponential function, which is g, actually let me write that in thicker. So g sub n equals to g sub 1 times r to the n minus 1. Okay, this is a formula to write any geometric sequence. G sub 1, this one right here, it's usually referring to the first term. Whatever your first term amount is G sub 1. Okay, R, kind of like rates, it's your pattern. What do we keep multiplying with? That number would go there. And then this n right here is number of term. So if I want to find the 10th term, then I put 10 minus 1 up there. And then this G sub n, okay, is the amount, I would say the result from term n. Okay, so if I were going to do use my sequence from here to write a formula, we would have G sub n equal G sub 1. What's our first term? Our first term is a 2, right? This is our first term. So I would start off with the 2 times, what's the pattern that we keep multiplying? It's also a 2. So this 2, it's our pattern. Okay, and we raise it to n minus 1. So if I want to find like g to the g sub 7, then I would substitute, sorry, I would substitute 2 times 2 to the 7 minus 1. I would put 7 up here, and then it'll be 2 times 2 to the 6th power, which is 128 when you put it in the calculator. Okay, so that means my 7th term would be 128. Okay, let's use some chart, because this is going to be very similar to your homework. Let's set up a chart. Let's say we start with 1, 2, 3, 4, 5, 6, and 10. Okay, we have to write an explicit formula. So this formula right here that we just created is called explicit formula. And these are the numbers that are given to you. Okay. So how do I create an explicit formula and also be able to find g sub 10 later? Okay, so the explicit formula, first off, let me erase this first. If we follow our formula up here, g sub n will stay as g sub n. And then we look at what's our first term. First term, it's a 5 times, what's our pattern here? How do I get to the next number? We technically add 5, but we can't add 5 to get to the next number. So think of the multiplying route. We multiply by 2. And if we keep multiplying by 2, we get to the next number. So 5 times 2 to the, and we're going to do n minus 1. Okay, they're only asking for the formula for the first step. And now if I need to find g sub 10, instead of writing n, we just need to write the 10 in there. Okay, so substitute. We write our 10 in here. Okay, and then we get 5 times 2 to the 9th power. So you are welcome to do this on your calculator. We get 5 times 512, which equals to 2,560. Okay, so if I'm going to go with my calculator, I'm just going to show you real quick how we do this. 5 times 2 to the, and you could have just write 10 minus, 10 minus 1. Keep it up here. Minus, I can't do that. Oh, because I put a minus. Well, we know it's a 9, so you can just put a 9 up there. And we still get the same answer. Okay? So you can go back and write 2,560 in that box. Let's do another example, but I'm going to go into your homework and show an example. Okay, so let's see. Again, your day 1 homework says write the explicit formula for each geometric sequence. So you gotta do this, and then use the equation to determine the 10th term. Round your answer to the nearest thousandth if necessary. Okay, so I'm gonna do number 6. Number 6, I see my first number, so I know this is gonna be my G1 later. But what is our pattern here? How do we get to the next number? It looks like we are dividing by 3, right? But if I can only multiply, that means instead of saying divide by 3, we have to multiply by 1 over 3. We are multiplying by 1/3 to get to the next number. Okay, it's really important to know what you're multiplying with to fit it in your equation, or fit it in your formula. So I'm going to start off with g sub n equals, remember our first number is 27, times our pattern is 1/3 to the n minus 1. So this is our formula. And now I'm going to substitute my 10 to figure out my answer. 10 minus 1. Okay, so let's go ahead and put this in our calculator. We got 27 times, let's put a parentheses for our 1/3. And then we gotta raise it. 10 minus 1 is 9, ninth power. Okay, and this is our answer, 0.001. Because 1,000, it would be 3 numbers after the decimals. So our answer here would be 0.001, approximately. Okay, so that's it for day 1. Day 2 homework, it's very similar, except you are writing an exponential function and also evaluate. Okay, so I'm going to show you one of the questions. Let me do number 1. What they mean by rewriting it in exponential function? Oh no, I don't know why the exponent went down here. But instead of writing a sub n, we're writing f of n. Okay, again, this power is actually an exponent. All of these are exponents also. So I'm going to rewrite it as 4 times 2.5 to the n minus 1. Okay, and then they want you to substitute 10 in there. So it'll be 4 times 2.5 to the 10 minus 1, which we get 4 times 2.5 to the 9th power. Okay, let's substitute. 4 times 2.5 to the 9th power. Okay, and your answer is 15,258.789. And that's your answer. Okay, so let me just go back to this one and go back to our front page real quick. This lesson will help you to do Monday and Tuesday's homework, and we'll have a Zoom meeting from 1 to 2 on Tuesday. And then for Wednesday, you're going to be working on Carnegie, which is Unit 6 Rational Models, Workspace 1. And Thursday and Friday, there will be another video coming out shortly. Okay, and your due dates are this coming Thursday and next Tuesday, May 12th. Okay, that's it.